Hello, everybody. So today we're going to be looking at Mendeleev, one of the early creators of the periodic table. So in your Edmodo, you are going to go to the post that says Mendeleev. It looks like Mendeleev, but it's Mendeleev. We have the link for the reading. We have the practice questions and my email that you send them to. So let's take a look at this. So what Mendeleev did, so a little about Mendeleev at first. He was a Russian chemist and a teacher, and he published a periodic table of elements. The following year, a German chemist published a very similar table, but Mendeleev is given more credit because his table was published first and because there were some important insights he made regarding his table. So he was actually writing a chemistry textbook, and he wanted to organize all of the known elements at the time according to their chemical properties. So he organized the information for each element that was known on separate note cards that he could rearrange as needed. And what he discovered is that when he placed them in order of increasing atomic mass, certain similarities in chemical behavior would repeat. So they were very chemically similar for the most part when he went in order of increasing atomic mass. Okay, so this type of repeating pattern is what we would call periodic. So for example, the orbit of the moon around the Earth is periodic. Pendulum swinging back and forth is periodic. It's a regular repeating pattern. So this is his periodic table. He organized things in terms of columns from smaller mass to larger mass. And the heading and all the other stuff you can't really understand because it's in Russian, but you can see some of the symbols like hydrogen, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So atomic mass, as I said, it increases from top to bottom of the columns, and then it has successive columns going from left to right. So in his table, the elements that are in the same row, horizontal row, so going left to right, are known to have similar chemical properties. One of his key insights is shown when tellurium and iodine were listed in a different order. So tellurium has a higher atomic mass than iodine, but it is listed before iodine because the properties of iodine are closer to those of fluorine, chlorine, and the other halide group, the others in the halide group. So what he thought was the reason for this is that one or both of the atomic masses was inaccurate at the time. Okay. This wasn't the case, but he was right to group the two elements together, or group the two elements as he did based on chemical properties. All right. At this time, if we can see, there are places where you see question marks in the table. Now, these are where there are elements that weren't discovered, but he kind of assumed what the properties of the element would be based on its position. You'll see this as far as gallium, and as far as germanium. He predicted what the properties of these would be, and he was actually pretty close. All right, one last thing in element number 101, which was synthesized in 1955, is named Mendeleevium after him because he was accepted as the founder of the periodic table. So make sure you finish your questions and turn them into me.